My name is Chris Goodacre. I'm the software development manager for Scripps Asset Management Group. With me today is Boehmann, who is the most senior software engineer and the leader of the team that helped us get to Graph originally. We'll be talking today about how we use Neo and have used Neo to federate digital asset management systems. So you might not know Scripps Networks, but you probably know our brands. So we are not Cisco, we're not Linksys, we're actually HGTV, DIY, Food Network, Cooking Channel. And this is sort of the beginning of the problem. So when you think about traditional television, you think about shows and series and episodes and maybe even different versions of those episodes. And if you want to get a little technical, video segments, so the time that's spliced in between commercials, it actually seems pretty simple. Here's a fairly elementary model of what that looks like. But the actual problem is a little different. So you start adding in real-life ideas like brands and channels and talent and production organizations and distribution rights, and all of a sudden your simple little model turns into something that's not quite so simple. And that, unfortunately, is only the start of the problem, because that's one digital asset management system. That's video, right? We're actually talking about production management, like distribution rights agreements, licensing agreements, the actual video, closed caption files, still imagery, audio files, and recipes, because after all, it's the food channel. I'm not even going to talk about this because we don't have a ton of time. Everybody knows point-to-point integration is an anti-pattern. You shouldn't do it. And guess what? When your digital asset management systems are a collection of SaaS and COTS and homegrown, from a practical standpoint, it's not even manageable, right? It's, from a schedule perspective, you can't even coordinate all the changes for the systems that you don't control in a way that actually allows you to meet your business deadlines. So we sort of settled on this model. It's pretty familiar to anyone who's ever done anything, right? It's a hub and spoke model. We have these digital asset management systems that are sitting at the edge of the wheel. And then we have the Scripps Asset Registry that's in the middle, sort of managing the relationships between them. All it does is it's the authoritative source on the relationships and our key identifiers across these systems. So the next question is, what do we use for this asset registry, right? You know, we could have used a relational model, but in the second or third slide, if that's one DAM, that's one digital asset management system, you can only imagine what all of them together, and there's not 6, there's really more like 10. And you have different concept definitions in each of them as well. So you have different roles for recipes than you do for video. And so it gets even worse. The other problem is we don't do the kinds of queries that relational databases are good at. We're not asking for what are the list of shows, or show me all the recipes that have cumin in them, or that sort of thing. What we're asking for is what are the relationships? What recipes are associated with this food channel show, this episode? Are there images? What are the people that are associated with this? Some are authors of the recipe, some are participants in the episode, some are the hosts. What are the production companies? Those are the kinds of questions that we are and our business is interested in answering every day. Our first attempt at this was a while ago. In fact, it was before the NoSQL movement. And our first attempt at this used an LDAP database. It handled very large data sets, had extremely fast reads, but we had some challenges. We had some operational challenges in terms of failover and we had some operational challenges in terms of failover, and more dramatically, we had some business challenges because the business was changing, but we didn't have a lot of schema flexibility in the LDAP database. So we're going from a world where we have what we call a linear schedule, right? We have something that's on at 8 and then something that's on at 9, and this repeats itself for every brand we have, to video on demand, subscriber video on demand, what we call nonlinear distribution, which is stuff that doesn't have a fixed schedule, that can be played anytime. And then again, after that business revolution, we have the next, which is social, Snapchat, Facebook, Pinterest, micro networks like Genius TV, Genius Kitchen. So the whole model about the show and the series and the episode, it doesn't really work anymore. It works some of the time, but not all the time. And we were having a difficult time adapting our LDAP schema to account for this. So our reboot on this, which was about 3 years ago, it was 2014, was to actually use a graph database to model these relationships, and specifically Neo. We needed new asset types, like short form and social, to be able to be added easily. We needed new relationships, collections of short forms that shared different aspect or shared the same root concept, but different aspect ratios to be able to be related in ways that we never could with linear distribution. And we needed to be able to easily and quickly query that relationship data. So that's the why on how we got to where we're going today. We tried a couple of different models, a couple of different iterations, and where we wound up was in a graph. Now I'm going to hand it over to Brant, and Brant's going to talk to you about a little bit about what the graph looks like.
Thank you, Chris. As Chris mentioned, my name is Brant Boehmann. I'm a senior software engineer and technical lead on the project at Scripps Networks where we did this. So let's talk about our graph a little bit. So we don't have a particularly large graph. I would say it's medium size in terms of graph. Back in 2014, we started out with about 10 million nodes. Today, we have about 43 million nodes. Our read to write ratio is about 400 to 1, so we do a lot of reading out of this. You can see our transaction volume there is about 3,000 requests a minute, not particularly high, and we peak at about 8,000 requests a minute. So in this time span between 2014 and 2017, we grew a little more than 4 times. And the important thing about this, what Neo4j has provided us, is our query times have been constant, just above 2 milliseconds per request, from 10 million nodes to 43 million nodes. So we run our graph in AWS. This is sort of the topology here of it. We have a cluster of 3 in HA mode. The database is running on EBS volumes on EC2 instances that are M.4.2 XLs. These are fairly moderately sized machines with 32 gig of RAM. We have 8 gig JVM heap and a 20 gig page cache. And that gives us a little room to grow because we've got about a 17 gig footprint on disk of the database. Interestingly here, we actually run 2 load balancers in front of this, both pointing at all 3 nodes, but utilizing the HA endpoints on the graph database to tell us which one is the master and which ones are the slaves, because we direct all of our writes to the master and we direct all of our reads to the slave. So this is the meta model of our graph. So you go back and you look at the model that Chris showed earlier in one of the first few slides. There's this huge ER diagram. This is it. We have assets. They relate to one another in one of several different ways, or many of several different ways. Those assets have instances. You can think of instances as some representation of the asset. The asset is a piece of intellectual property. The instance is a file that represents that piece of intellectual property. So maybe it's an MP4 video, maybe it's a XML recipe or a PDF recipe or a JPEG image. And we track the location of where that file lives globally. So it might live on-premise in our headquarters in Knoxville, Tennessee. It might be on a storage system in the UK. It might be in Amazon Glacier or in an S3 bucket. So here's a small snippet of our graph. At first, you might look at that and think it looks just as confusing as that ER diagram. And to a point, this is true. However, what you're looking at here is actual data, not a model, right? So we're going to zoom in on 3 different sections here and talk about what's happening. And to Chris's point, we have multiple dams and we're relating assets across dams. So these nodes are coming from different dams, registering them in. So the first one here is broadcast video. So we have a linear scheduling model where we air things at 8 o'clock, 9 o'clock, 10 o'clock. The first on the top left there you'll see is this show. So this might be one of your favorite shows like Fixer Upper or House Hunters. And there are seasons, or we call them series, associated with that. So maybe this is the first season or the 3rd season or whatever. That's part of that show. And down to the bottom right a little bit in the middle there, you see an episode. So this is one episode of that particular season. And that season has segments. So you can see these are related on this part chain all the way through because a season is part of a show, an episode is part of a series, and segments are part of episodes. Over time, what we ended up doing is creating versions of episodes. So it wasn't just an SD network anymore, right? HD came out. And we started leveraging our episodes for more purposes. We want to shave 30 seconds off to move it from HGTV to DIY and put more advertising in them, or condense them for use on other platforms. So we started, you see this incoming relationship into that middle episode, a version relationship. So any given episode may have many versions. In our existing system, what we were noticing over time is that, well, I want an inventory of our episodes, sure. I want to know what I can license internationally or what's available for use on a given platform. But my numbers are off, right? So I'm trying to get utilization of my episodes because I have 5 copies of the same episode that are slightly different from one another. So over time, we introduced this concept of an abstract episode. And it's really just there to group all of the different versions and give us something that we can license internationally or that we can count distinctly. And this would have been difficult in our LDAP model because it would have been a schema change. All those relationship types were a schema change every time I added one. The ability to dynamically add relationships based on business need is the real power that we get out of this. The second section of this subgraph illustrates some recipes, right? So there's 4 recipes stacked there in the middle. That top recipe has a couple instances. This is probably an XML version and a PDF version of this recipe. And it's showing that those are located in an S3 bucket. And you see there's a reference relationship between that abstract episode on the left and the recipes in the middle. So this is giving us the ability to track what recipes are related to what episode. The third one here is just showing us yet another dam in this same picture. These green boxes are our assets. our green circles are our assets, the blue circles are our instances of those assets. And these would all also relate into either concrete episodes or abstract episodes or potentially shows and series as well. So I mentioned the ability to create dynamic relationships as the business changes. So we saw in that first subgraph linear content. So for a very long time, we were a cable network, right? We aired things linearly, but the world's changing, right? People aren't turning on the TV and watching it, you know, whatever's on, I'm watching, right? I view video on demand now. I go on social networks and I watch clips of video. So we're really shifting from this linear model to what we call a nonlinear model. So I can effectively watch that video whenever I want, depending on what platform it's available on. And we produce content now not strictly for our linear networks. We're producing it distinctly for those nonlinear channels. So in this case, on the left there, you see an episode, and there's two segments of that episode. And you see a nonlinear video there in the middle that's derived from two different segments. So maybe I'm taking the first two segments of an episode or pieces of those segments, and I'm making another video for use on another distribution channel. And you see there's a part relationship there. This nonlinear video was part of those segments. On the right side, you see two more episodes, and you see two more nonlinear videos, but those aren't parts. Those are reference relationships. So this allows us to define what is the intent of this relationship. So this nonlinear video is related to this episode because it references it in some way. This is probably some kind of outtake from the production company, some bloopers or something like that we're storing the video of because we want to keep it and leverage it because everything's monetizable. In the middle, there's a nonlinear video that's not related to any episode. And this is our platform now for uniquely creating content that didn't come from an episode that we aired on a linear network. And you can see that these things are then grouped in at the top and the bottom there into collections. So I can create collections of our episodes or collections of our nonlinear videos, and I can basically create a SKU out of that, and I can sell that to some partner or deliver that to a Hulu or a Apple or any of our other nonlinear partners. So one of the key aspects we get out of Neo4j, we talked about the nodes and relationships there, and that's what I like to consider the right abstraction for the problem we're trying to solve, right? When I think about how our assets are related to one another, I think about them in terms of a graph. This asset's related to that asset. What I don't want to do is try to model that relationally and think, okay, so that's a record in the asset table, and there's this cross-reference table, and if that primary key is related to that primary key, that means they're related, and so on and so forth. So I get the right level of abstraction when I think about the problem when I'm querying. Then I get this level of simplicity, right? So the Cypher query language gives us this very terse syntax that's very, very expressive and really means what I'm trying to say. So on the top right is an example query that we have. So we have an internal application that plays our videos. We have what we call video proxies. They're low-res copies in the same aspect ratio with the same timing as our episodic or nonlinear content. And that video player needs to be able to, play the various segments of that video so people can QC that video or people can sort of browse through it looking for particular content. So that top right query, we're basically saying, hey, give me the asset that has our SCRID, that's our Scripps identifier. Find me all the segments of it through the part relationship. Find me all the instances of type frame accurate proxy. And find me all of those that are located in our EDAM S3 cache. It's just a system that we have where we're caching things. So it's basically pulling back the URLs for those locations, and we're feeding those into a video player. It's a very simple query. On the bottom left, is another representation of something we might do, where when we deliver video to a company like Hulu or Apple or Google, we're contractually obligated to deliver more than just the video, right? If there's recipes associated with that, we might be sending them the recipes or photos of the talent or, music cue sheets or you name it. Lots of production deliverables come in that are just related content. So that basically traverses down through all the parts that are related to any particular asset. This might be a show level or a season we're delivering or a single episode. Traverse all the way through that, finding all the things that are related up to 10 levels deep, because we don't typically go deeper than that, and filter that by any asset types or instance types that we might be contractually obligated to deliver, bundle all that together, and send it out. So, in summary, our business has a collection of dams. We use the best of breed approach across those dams. So sometimes that's custom development, sometimes it's COTS, sometimes it's a SaaS system. But the systems weren't orthogonal. They needed to interact, and the business demanded interrelationships between those dams for their different use cases. We had operational challenges that led us away from certain types of systems and drove us towards a graph model, and we settled in nicely with Neo4j. And Neo4j provides us modeling flexibility and simplicity, and really the performance that we could get out of Neo4j also helped us out a lot. So that's all I've got. Finished a little bit early today, but got time for some questions if anybody has any. Nope. Okay. Thank you very much.